Okay, I was having a little trouble here with the situation, so starting over again. When you've got these 5 different ones, they all have the same 3 types of books: history, science fiction, and nonfiction. These are not considered duplications if you're dealing with permutations, because they have to have a determined order. So this would be a different one than this because the order is different. But when you're dealing with this type of thing, if you've got 3 books like this, that's really the same thing as the 3 books here. And that's where something called combinations comes into play. Okay? In a combination, EF is considered to be the same thing as FE. So you end up dividing by a lot more than you have before. This right here, the things on the bottom are going to add up to what's on top. So if you got a combination of 6 items, take them 4 at a time, on the bottom of this, you're going to have 4 and 2 add up to give you 6. And it always works that way. Okay? This would be the permutation that we've been dealing with, president, vice president, is different from this president, vice president. In a combination, it's a committee, it's not different. Okay, so this right here, if you are selecting 4 paintings out of 20 to be on display, then that would be a combination because it really doesn't matter what order they happen. So you get the combination of 20 and 4. And this right here is 20 factorial over 4 factorial and 16, because 16 plus 4 gives you 20. Put that right into your calculator and you should get 4845. Okay? So, could do that right there. Combination of 20, I'm not sure exactly where I left off because I thought I was recording and I was not. So, this was a combination because the order was not important. And we ended up with 4845, which I showed you on Desmos. You just pick the NCR instead of the NPR. And then we went here. How many different committees? A C combination. You're taking 5 people out of 15. And a committee of 5 if each student has a different responsibility. This means an order is important. Again, 15 out of 5, but it's a permutation this time. This one is if you've got 8 girls and 7 boys, how many committees of 2 boys and 3 girls can be formed? Well, you're going to group the girls together and you're going to group the boys together. Order's not important, but you're going to be taking 3 girls out of the 8 and 2 boys out of the 7. And you'd multiply them together, so it would be part of the counting principle. Okay? And that's just what this is showing right here also. This. Ms. Sloan asked her students how many ways 5 patients in a hospital could be assigned to 7 identical private rooms. Anita said the problem dealt with 7 combination 5. Sam disagreed, saying this was 7 permutation 5, which is correct. It's a permutation because once you assign somebody to a room, you can't assign anybody else to that room, and it's an order is important. You're not going to have the same sort of person coming the second time. Okay. This one, you've got small, medium, large, and extra large, blue, green, and gray. There are 4 choices here, 3 on each of these, so you will have 12 different situations on here. Okay. Basic counting principle. A restaurant offers the choice of an entree, a vegetable, a dessert, and a drink for a lunch special. If there are 4 entrees, 3 vegetables, 5 desserts, and 5 drinks available to choose from, how many different lunches are available? It would be 4 times 3 times 5 times 5, which is 12 times 5 is 60 times 5 is 300. Are choosing a movie to see and choosing a snack to buy independent or dependent? They would be independent because choosing your movie has no effect on choosing a snack. You still have all the snacks available once you've chosen a movie. If a group of 10 students sits in the same row in an auditorium, how many possible ways can they be arranged? Well, once a student sits down, they're done. They can't sit anywhere else. So you would actually have the same thing that we had earlier. I can get up there. I'm not sure I can. We had the same here when you had people sitting in the row there. Once the person sat, they're done. So you've got 3 million different ways this can happen. Okay. How many baseball lineups of 9 players can be formed from a team that has 15 members if all members can play any position? They're not actually talking about a lineup, which would have an order. They're really just talking about how many teams could be formed out of 15 possibilities, which would be a combination. Okay? Because they can play any position. All right. Now, the last one, this is really just trying to get you used to being able to put these into a calculator. So it would just be a matter of permutation of 6 objects taken 6 at a time. Okay, which is 720. That really just comes down to 6 factorial. So they really just want you to put these into the calculator and get an answer from those, which is not too difficult. But that's it for prerequisite information that you need to know before we go into binomial distributions.